here at Gradle Build Tool. And with us today is Rodrigo. He's the principal software engineer for the Gradle Build Tool. We have the whole team behind us. And so if you have any questions, then make sure you put your questions on the YouTube chat, and you'll get them answered kind of in real time as we go along. So first off, some of you might not know what the Gradle Build Tool is. So our goal is to enable you to kind of build anything, automate everything, and deliver your product faster. And so one of the things that we've done is we have the configuration cache, which is going to speed up the configuration stage of your build. If you don't know about us, we are trusted by millions of developers, and TechCrunch has said we are the top 20 open source project. And so if you haven't used us yet, then this is a perfect time for you to kind of get in and see what Gradle Build Tool is and actually contribute to the open source project itself. You don't need advanced Gradle understanding to actually participate in this hackathon. So if you're kind of new to Gradle and just want to start in open source, then this is a good entry point for you. So one of the reasons that you probably are here is because you learned that we have some swag available. And so everyone that has accepted PR can get this amazing configuration cache t-shirt where we have our Gradle elephant that is in rocket boots, indicating how fast you are going to be with the configuration cache once it is fully stable. Now, as further incentive, as we are going to have a lot of PRs and a lot of issues that are solved, the team and the community is going to vote for the top 3 PRs, and those contributors can choose from some of the commemorative shirts that we have that are designed by our very own Gradle Build Tool team. Okay, so with that in mind, now everyone is up to speed with what Gradle Build Tool is. Let's kind of learn a little bit more about what is the configuration cache and everything else from Rodrigo.
Hello, everyone. Thanks, Amanda. So let me see if that will work now. I'm sharing my screen. And I guess my screen's frozen. So welcome, everyone, to the very first worldwide Configuration Cache Hackathon. First of all, I would like to thank you all for joining us in this journey to the experimental configuration cache feature to a stable Gradle feature in the near future. A stable configuration cache will mean the APIs will no longer be subject to, will be working reliably and correctly for all use cases we know of. So your help is crucial. So with this event, we, the configuration cache team, want to raise awareness about the configuration cache first and get more people to play with it, and hopefully to start take advantage of the configuration cache sooner rather than later, so we can learn from your experience. Right? And of course, like Amanda just said, to give some swag away. Let me talk about the agenda quickly. So this presentation will be split in 2 main sections. In the first, I will introduce the configuration cache feature, explain its benefits and some of the changes it brings to the Gradle programming model. And in the second section, I'll demonstrate how to make contributions to the Gradle open source code base, starting from scratch, but focusing mainly on the subject of the hackathon, namely fixing or improving the documentation snippets to be fully compatible with the configuration cache. So you can help us to in fact, right, how long the stable configuration cache release cycle will depend on your help. So by enabling the configuration cache and providing feedback when things don't work, or by providing feedback to plugin authors when their plugins don't work as well with the configuration cache, by making your own plugins compatible with the configuration cache. And finally, by making contributions to Gradle itself, which I hope after this presentation, you'll be very equipped to do so. So first, what is the configuration cache? So the configuration cache is a still incubating Gradle feature that significantly improves build performance. It does so by caching the result of the configuration phase. I'll get into more details about that later. And reusing that for subsequent builds. It's sort of like what the build cache, if you are familiar with the build cache, what it does for task execution by caching the results of tasks and reusing them. The configuration cache can do the same for the configuration phase. So you can have an idea of the sort of performance improvements you can get with the configuration cache. Of course, it really depends on the structure of your build and how long the configuration phase really is, right? But it's definitely the next major milestone in Gradle build performance. But just how does the configuration cache help improve Gradle build performance? Well, the first, most obvious way is by skipping the configuration phase entirely, right? By saving on CPU and memory consumption. The configuration cache also enables all tasks to run in parallel by default. I'll discuss a bit more of that later. And by caching the results of dependency resolution, so it doesn't have to reevaluate dependency resolution specs over and over. That's how we get this fast builds, right? So I'm going to try to share my screen one more time because I need to demo. And I see that's not working. If you can still hear me, I'm sorry, but my screen has completely frozen.
It's the normal problem with demos is they always break when people are actually watching, right?
Okay, you can hear me.
Mm-hmm.
Okay, yeah. So maybe if I turn off my camera and try to share, I can still demonstrate what I wanted to demonstrate. So I'm going to try that. Okay, so it seems we're back. I'm really sorry, everyone, for that technical difficulty. So you can see my screen now. Yeah, and I can actually control it. Isn't technology wonderful? So as I was saying, let's have a quick taste of what the configuration cache can do for our builds. So I prepare a small demo for you here. Just checking, can you still see me and hear me and see my screen? Great, thank you very much. So let's go there. So I'm sorry for the resolution if that doesn't look right, but it was the only way that screen sharing finally worked. So let's see if we can take it from there. So I have a very simple build here trying to demonstrate and simulate some slowness in a build, right? So I have two tasks defined here. One is a very slow task. It takes 2 seconds to finish, and a very quick task that doesn't do anything, so it just returns quickly. And we have just a slip, right, in our build script to simulate a slow configuration phase. So I'll go ahead and execute Gradle quick. First, I'm going to execute without the configuration cache so we can see the effect of cache has on the execution. So first we can see that the build would take at least 6 seconds, right? We have two tasks that together take 2 seconds, 4 seconds, and we have the 2 seconds for the configuration phase. So this should amount to 6 seconds. The very first time Gradle runs, right, it has to bring the daemons up, so it takes a bit longer, but we should see it converge to 6 seconds. We can also see, right, that the tasks are not executing parallel, so I'm going to enable parallel execution by using -- parallel. And as you'll be able to see, unfortunately, that won't have a big effect on the build performance because Gradle cannot really run these two tasks in parallel since they are in the same project, and Gradle doesn't know enough about the tasks to let them run in parallel. So now I'm going to enable the configuration cache. The configuration cache can be enabled with -- configuration cache. One of the ways we can enable the configuration cache. And this time, we should see it executing much quicker. It's doing that because I already had primed the cache before, so we could see the effect immediately. So the first thing you might have noticed is now that the task ran in parallel and they finished pretty quickly, right? In this case here, we are lucky because the configuration cache just works, but the configuration cache does bring some new constraints to the Gradle programming model that I want to discuss with you. So going back to the presentation, let's see, how does the configuration cache actually work? So in the first build, right, we're going to have Gradle executing all the phases as normally, right? We tend to say Gradle has two phases, the configuration and execution, but formally in the code, we define 3 phases. There is an initialization phase where Gradle will run init scripts and the settings script to figure out the structure of your build, which projects it has and all that. Then it builds the build source project if present, or any build logic that you might have in your build. And then finally run the build scripts and build what we call the execution graph or the work graph, right? And that's the graph that represents the tasks that actually need to execute to fulfill the request that you posted to the command line. Right? So in the first build, everything runs And after the execution graph is computed, is stored to the configuration cache. In the second build, the execution graph will be reloaded directly from the cache if and only if no build configuration inputs have changed. Right. So now we have this new thing to worry about, or at least to think about, right? The build configuration inputs. So how does this change to the way Gradle executes tasks affect the programming model, right? So we can see that the configuration phase and the execution phase now, they can be split across JVMs, right? In fact, you can have, whereas before in Gradle, you would have every configuration phase corresponding to a single execution phase. Now, a single configuration phase can actually yield many execution phases that will run on different VMs. So the first thing that happens, right, with that new model is that tasks are no longer allowed to at least reference in their state any live JVM type references, right? At least these references cannot cross this boundary between the configuration phase and the execution phase. It's perfectly fine, right, for a task during the execution phase, do whatever, and it's perfectly fine for the configuration phase during the configuration phase, do whatever. We can't just allow is the sharing between the state between these two phases, right? So another implication is that tasks can no longer rely on singletons, right, or any sort of static state to cross these boundaries, right? Because and that's a common problem that you might face. That everything seems to work because Gradle has these daemons behind the scenes, right, to keep all the state in memory, and then you think, okay, my build is actually working, and you go home next day, you try to execute your build again, and now you get very weird failures because the singletons or the static state is no longer there because there's a new daemon around that doesn't have that state. So the second important constraint that the configuration cache brings to the Gradle programming model, and that's to enable the parallel by default execution of tasks, is that tasks are now isolated from each other, right? So you need to be careful not to share state, and in fact, Gradle will do its best to forbid you to share any state between tasks. So things like the Gradle model types, like scripts, projects, configurations, source sets, or dependency resolution types, at least the classical ones, they cannot be referenced by tasks because otherwise tasks would be able to interfere with each other. So tasks are not allowed to reference other tasks directly anymore. So a common pattern that many Gradle users are probably familiar with is the configuration task pattern, where you have a task that will actually at execution time configure another task. That's no longer possible within the configuration cache model because we want to execute tasks in parallel, and we need to make sure they are isolated and cannot interfere with each other. So the next thing the configuration cache does to prevent tasks from sharing state is that any referenced extensions by a task or beans or anything, any data that you have in the configuration of your task will be like deeply copied into the configuration cache and cloned. So you might have in the vanilla Gradle execution model a task and another task sharing references to the same extension, right? And then could share state that way. That's no longer possible with the configuration cache. We have alternatives like shared build services that I won't be covering here today, but they are covered in documentation. The next thing is we don't allow the build listeners anymore because mainly because the callback based nature of those APIs doesn't play well with the new serialization model that we have. We are working on new APIs to replace these capabilities. And it is part of the stable configuration cache plan to have those replacements ready before we can declare the configuration cache stable. And the next, right, and very important implication is that build configuration inputs are now a thing, right? So now we have to care, or at least be aware how our build is using the environment, is interacting with the environment, so we can optimize and get less or fewer cache misses, right? That's the idea. So what are build configuration inputs? So build configuration inputs are everything that would contribute or affect the configuration of your build and finally of the execution graph, right? So we can think init scripts, setting scripts, build scripts, Gradle properties files, system properties, environment variables that are used during the configuration phase, configuration files like verification, dependency verification, metadata, things like that. They are used also during the configuration phase or might be used. Build source or any type of included build logic, configuration inputs and their source, the source files also of those build logic builds. And they are mostly automatically detected. We are constantly improving the detection to cover more and more cases, but it is no panacea yet. So they're not tracked yet. And for just one example is like if you query a file collection during the configuration phase, right? And then take decisions based on the results of that file collection. That's not being tracked and could cause, right, a false cache hit, because Gradle would not see that a file that was indeed necessary for the configuration of the build, right, that it has changed. Another source of these issues are the I/O APIs of like the Java I/O APIs, or if you're using Groovy, the Groovy I/O APIs and Kotlin I/O APIs. We have coverage for some of those, and we are working to cover more ground, but this is something to be aware of, right? And this is something where you can help us, right? Whenever you find a scenario that you think, oh, it should be a cache miss, right? But I'm getting a cache hit because Gradle didn't notice that this file has changed. So that's where you can help us by reporting those sort of issues, right? That would be really helpful. We are also extending the provider API to cover more scenarios that would be otherwise very hard with the standard APIs available to Java, Kotlin, and Groovy. So we have APIs to query like subsets of environment variables, subsets of system properties, and APIs that allow environment variables, Gradle properties, and system properties to not be considered build configuration inputs at all, right? So if an environment variable is just a task input, we have APIs to help in that case. I'm going to be demonstrating some of that later on. So the contents of files, we are now covering with provider APIs. And more importantly, the output of external processes is now something that we can also support with the new APIs. So imagine you are running Git to figure out the hash of the current commit. That's a very common use case, right? And you're using that hash to configure some task in your build, right? So when the hash changes, when the commit changes behind the scenes, right? You want Gradle to then reconfigure the task. And when none of those APIs are sufficient to cover your scenario, we have the value source API. So I'm going to demonstrate troubleshooting a more complex example of a build. So again, not a very complex build, so we can focus on what really matters, right? And here I have a task that has an input that is just a directory in the file system. You can see here. And an output that is given by a system property. Right? And in the do last action of this ad hoc task, we are simply reusing the project.copy functionality to copy the source to the destination. So let's run that with the configuration cache and see what happens. So I'm going to run some task. I'm going to pass the system property, some destination to be my build directory. I'm going to enable the configuration cache. And just for good measure, oops, I'm going to enable rerun tasks. Just in case I have run this demo before, otherwise we might not see some of these problems popping up here. So whenever the configuration cache or whenever Gradle finds violations to this configuration cache constraints, right, you will report and complain. And by default, you would Gradle will fail the build whenever violations of this new programming model are found. And we can see the first violation here is that it's saying that my task, it's invoking task.project at execution time, and that's unsupported, right? And in fact, we have good documentation on all of these constraints, so we can navigate there. And oops, so I'm gonna actually copy this URL. So tip here, so you can always change that to current and go to the right page. And you can see why and how to fix, right? So we have documentation on other disallowed types, things that I already described. So it's all there. And you can see all the problems, right? So first here is just a small summary of the problems found, but we have a complete report of all the problems found. So I'm going to do the same. Copy these. And in this view, we can see the problems that were found, and was just one in this case. And they are grouped in two different ways to help you. First, when problems are grouped by message, you can see what sorts of problems you have in your build. It could be that you have, okay, hundreds of tasks failing, but they are all the same problem, right? It's just task.project. So that's why this view is useful. And we also have the problems grouped by location, so you can quickly pinpoint like which tasks or which plugin is actually giving you trouble. So by looking at this, and we certainly could make this stack trace more helpful, but just investigating this problem here, I might be able to find where the violation is coming for, and I can find it here, right? So my build script in line 7 has this violation, right? This is the name, the syntactic name for how Kotlin compiles scripts to classes. So build Gradle KTS line 7. Let's go there. So of course, this is our project access, and that's not allowed anymore. So what do we do, right? So we introduce a few APIs that as replacements to most, if not all, important project capabilities. And that's how we fix this issue. So, but before doing that, before actually fixing this issue, I'm gonna turn this task into a proper Gradle task, because that will make easier to acquire the services that I need, right? So I'm gonna create a task. And so if I'm using copy, and actually, oh, I wanted to show you at that documentation page exactly which service you can use to replace. There's a table with all the functions from project and the services. I happen to know exactly the service I need, so I won't bother you with the page again. But just by navigating from the report, you can get that, right? So, and that's the file system operations service. So Gradle can inject those services into our task. We just have to declare an abstract property, and Gradle will inject the service for us. And then we can create, right, our task action. And here I'm going to apply a recommended Gradle pattern, which is to split the configuration of a task from the execution of a task, right? So in the previous version, or still in this version of the script, we have everything in the same place. We have the configuration and the execution. But I'm gonna leave the configuration of the task here at the configuration block at the build script, but I'm gonna make my task more reusable and hopefully more useful by letting it be configured, right? So the original task takes two directories, right? A source and destination directory. So that's what we're going to do here. We're going to have, let's say, a source directory property and a destination directory property. So the source will be a input directory, and the destination will be an output directory. Right? And now we can basically copy or move the execution logic to the task and replace that by the file operations, and it's basically the same, right? Except that now I should do this. And here we're gonna just configure our task. So now we have our new copy task. And I'm gonna say this prop. So I can then say source set. So I cannot just say, right, source here, set source, because this is a string. And set for this directory property actually expects something richer, richer type, a directory or a file. So what I'm going to do here is that I'm going to use another service, right? So the layout service can give me a dir, so we can actually base that source directory from the project directory. And for the destination, I'm going to do the same. In the destination prop. Something like this. Oh, let's make this a little shorter, shall we? Yes, and that'll be the project there. Just to read some of that code. So now if I run this again, right, I should see, or I should no longer see that violation. So I'm gonna do that again. So I have the rerun tasks to make sure I don't just skip the execution if the results are still cached. It wouldn't be the case here, but let's leave the command line like that. So this time we see that 0 problems were found, right? We still show you the link to the configuration cache report, because in this case, it has some important information for us. And that's basically, we have one build configuration input. It's saying, okay, there's a system property, some destination. And when the value of that property changes, the configuration cache will be discarded. So let's see how that happens, right? So I'm going to execute this once more. This time I'm going to say best. I'm going to move this time. And no problems, right? Everything executed. But we can see that the configuration cache entry was stored and it wasn't reused as before, right? So the first time we execute this, we had, let me run one more time so we can see this. Yeah. Have the configuration cache entry reused message. And if I change the property one more time, right? Store again. So that's a problem, right? Because the only thing this property is used for is to set the target of that copy task. It's not really used at configuration time. We're not taking any decisions at configuration time. So it would be good if we could let Gradle just pass the property through to the execution phase for us, so it doesn't have to invalidate the cache. And that's possible with the new providers that we have. So we have a provider for system property. And that's it. That's all we have to do, right? And now, if a provider returned by one of these build configuration input providers is used at during the configuration phase, Gradle will remember that fact and will invalidate the cache properly when those properties change or those values change. And if the property is only used at execution time, right, during the execution phase, then Gradle won't invalidate the cache at all. So let's see that. I'm going to just use the same. So it was stored because I changed the build script, of course. So now I'm going to just try, yeah, that's 42. And we should see configuration cache entry use this time, because now we're passing the system property all the way to the execution phase, right? So to summarize, to recap what we've seen so far, the configuration cache is an experimental Gradle feature that improves build performance. It introduces some changes to the Gradle programming model. It must be explicitly enabled at this point. In the future, we expect the configuration cache will be the default mode of operation of Gradle. And the configuration cache report is your friend in finding any of those issues. Sometimes it's that friend that talks a lot but doesn't say a thing, and you don't quite get what they're saying, but it's still your friend. And we can use your help to improve and figure out where we are missing capabilities with the configuration cache. So now I would like to go to the second section of the presentation and talk how you can contribute to Gradle by using the workflow the configuration cache team prepared for you. So in the announcement to the hackathon, you got a link to this repository. And now you can find a few documents there. You can find all the description there. And we have provided a suggested workflow. So let's take a look at that. So the first thing that we suggest is that you become familiar with the configuration cache feature. And by attending this event, or maybe by watching this later, you probably have enough knowledge to start with the hackathon, but I would still recommend you to go through the documentation. There's a lot of important and interesting details there that can help you, right, optimize your builds. And you definitely want to check out the Gradle contribution guide. Lots of important information there. You want to check our code of conduct and all that. But I'm going to focus right now on how you can contribute to Gradle in the context of this hackathon, right? So the first step that we have here, right, to start participating in this hackathon is that we have to claim an issue, right, in the hackathon board. So let's open this board and see what's there. So we can see we have an unclaimed issue here. After the live stream is over, we're going to populate with all the issues for you to start browsing and choosing what you want to work for. For now, let's focus on this one. Right. But before I actually go there, I want to talk about one more important detail here, and that's the rules of engagement. These rules are meant to maximize the participation, right? So we want the greatest number of people to participate and be able to play with the configuration cache and get their swag for doing so. So there's some time limits that you should be aware of. So, and first we have this rule that there's only one issue at a time that any contestant can claim. And we have these two limits. We have a 72-hour limit of progress on an issue, let's say from claiming the issue to submitting a PR and making some steps towards fixing the issue. And when you are ready to submit your contribution, right, you would mark the PR ready to review. And then there's another time limit of 48 hours to respond to any review requests. And we're doing that, again, to maximize participation during this month-long hackathon. So let's go back to the workflow document. So as I was saying, first we need to claim the issue, right? So let's go back to the board. And the way you claim an issue is by just posting a comment to the issue saying you want to claim. I mean, you can post anything. And when you do so, a member of the configuration cache team, so I'm going to put my Gradle hat on here so I can actually do this. So I'm going to move this to claim the issue now. Cool. So now I'm ready to work on that issue, right? So the first thing you want to do after you have that issue is to make sure you can reproduce whatever problem that issue points to. And we're going to see more of that. We're going to take a look at the issues more closely. But let's first start by forking the Gradle repository. It's enough to copy the master branch. So let's create that fork. So that might take some time. Should be quick. So I'm gonna just go there, my hackathon, and start cloning. So while that runs, let's take a look at the issue again and see what's in there for us. So the issue has all the information you would need to both reproduce the problem and understand what you need to do to fix the issue. What are the problems that were found, and what sort of build scripts you need to change there. So in this issue, we have build scripts in Groovy and Kotlin. So it's okay. I'm proficient or relatively proficient with both. So I'm not sure how many issues we have that require all that knowledge, or if we have issues that require only Groovy or Kotlin. I guess the configuration cache team can help me with that, answering that. And in the issue, right, you find first the most important bit of information, right? It's where this sample project is located. So you can actually start working on that. And it has the problems that were found, right? And another very important piece of information is how you actually reproduce the problem on your machine after you have cloned the repository. So I'm going to copy this for good measure and start reproing this. Okay. So I'm going to go to my clone. And before I do anything, right after I clone a repository, you probably want to make sure you have your user email configured and your username configured. Now I can just start this. This should also take a while, so let's take a look at the issue again and see what's there for us. There's another interesting piece of information here. It says the documentation pages that include this snippet, right? So we can see here that there's actually a ASCII document in the Gradle code base that references this sample. And those ASCII doc pages, they become part of the Gradle documentation. So this is relatively easy to map to the Gradle user guide. So you can see it's user guide, dependency management, something about transitive dependencies, resolution rules. So let's see if we can find that in the Gradle user guide. Let's open an arbitrary one and we go from there. Oh, because now my fonts are too big. I don't see the sidebar. So it was something dependency management, right? So working with dependencies and something about transitive dependencies, and then resolution rules, I guess. Resolution rules, that's it. Resolution rules. So if we look at this document, we can see that it has the pros describing, right, whatever is describing here, and then we find the snippets. And these are the snippets that we're going to see, right, and fix during this hackathon, right, all of this. So let's go back to our issue. Find where this sample is located. Okay, so it's still running. That's okay. We can so I can cd into that directory that I just copied. Oops. And let's see what's here. Yeah, we can see, like the issue mentioned, we have Groovy and Kotlin build scripts, but we also have this tests folder here. Let's see what's that. So that's where you find the actual test specifications. We use a framework called Exemplar, and it's a golden testing, if you know what that means, type of framework, right? It executes some processes, can execute a process and then compare the output against an expected output file, that sort of thing. And by looking in those files, you can see the exact command and tasks that are used to run, right, the test, the offending test in this case, so you can replicate the execution. Okay, so this test that is failing, right, in this sample is calling the resolve task, right, using Gradle. So let's take a look again what we have here. So we have Groovy and Kotlin. I'm going to start with Kotlin because Kotlin usually provides the best content assist in the IDE, right? But here we have a problem, right? So I have a Gradle project here. So each sample is organized as a full Gradle project, at least most of them are, that can be imported in the project, in the IDE, except they have no Gradle wrapper, right, configured here. So there's no Gradle configured for this project because they're executed as part of the Gradle build, and the Gradle build will configure Gradle properly for these samples before executing them, right? So what we can do here, so there are a few alternatives. The one I prefer, we actually document a different way of doing that in the workflow document and in the FAQ. So you might prefer that, you might have your own workflow. So what I'm gonna do here, I'm gonna basically copy the Gradle wrapper from my root directory into this directory. So then I can import into the IDE, right? So we are, right, if we count from the Gradle checkout, right, we have 1, 2, 3, 4, 5, 6, 7 directories. So I can do something like this. The root is 7 directories away, and then I can copy the wrapper, and I can copy the Gradle W scripts, right? It's not, I guess, not nice to see, but it's effective. So I'll take it. So now we have a proper Gradle project that can be imported into the IDE, and I'm going to do just that. So let's go back to the issue and see just one more time what the problem was. So it's saying task consumer resolve something, right? So we need to run consumer resolve. That's our culprit. And actually we saw that here too, right, in the sample conf. The issues will have all the information you need, but if you ever in doubt, you can look at the sample conf files and see the exact command and task that are being executed there. Okay. So let's take a look at this consumer script. So first interesting thing here that calls my attention are these tags. And this is how the Gradle build infrastructure extracts these snippets from these samples, from these full samples, and place them in the docs, right? So you can see begin and end tag for each of these snippets. So it's important to keep in mind that whenever you change any of these snippets, they are in between the opening and closing tags. You probably have to adjust the prose, so you might need to go to the ASCII document and adjust the prose a bit to make sense with the new sample structure that you come up with. Of course, we are ready to help with any doubts and review, and we can discuss all those details during the review process. Interesting. So this is not broken. So I'm gonna make it broken. It was just a mistake on my part. I access the wrong clone, but it's okay, right? So it was a clone that was already fixed. So now it should be broken again, and we can start from here. So this is the original sample. I'm gonna go to the console here and do exactly what the sample conf and the issue tells me to do. I'm gonna enable the configuration cache when I do so. So let's see. I really hope you will fail. Cool. And here we can see the exact same problem that we found in the issue. So this task, consumer resolve, and this is a different one, right? We haven't seen that before. It cannot serialize Gradle script object references. And when we look at this script, it might not be obvious at first. So why a script object reference is being captured here, right? And whenever you see that problem, it means that in any of these task actions, right, these closures, these lambdas, we are accessing, right, especially the execution time ones, right? We're accessing members from the enclosing script scope. So for a build script, a build.gradle.kts script, the enclosing object, the enclosing scope is the project object. So that's why we can refer to any members of the project object directly without mentioning like project dot something. I could write that and maybe that would become more obvious, although it'll be a different type of problem because now this project is coming from the task. But we can see that these configurations method actually belong to the project object. One of the objects, right? One of the Gradle model types, tasks are no longer allowed to reference. Right? So what do we do here? Right? So the fix for those types of issues is usually making sure that we only capture the information that we actually need to pass on to the execution phase. So I'm gonna, yes. So basically extracting the runtime class path to a variable. And now I'm no longer, right, accessing the configurations method inside the closure. I'm only capturing the single piece of information I need to pass from the configuration phase to the execution phase, right? It's a bit more, it's a bit trickier than it might seem at first. So let's run this one more time and see if that will fix the issue. So at this point, I might want to, well, let's see. So that seems to have worked, right? But remember that the configuration cache stores the information, right, on the first build. So Gradle will store the execution graph on the first build, and we'll try to load it on the second build. So it's very important that as we work on fixing these issues, we run those tasks twice to make sure we can store the execution graph properly, and then we can load the execution graph properly. Because there are errors that can only be caught when Gradle is loading the execution graph. So let's see that. Excuse me. Yeah, so the configuration cache entry was reused, but there was one problem. So it's saying, okay, there was a configuration cache entry, but as Gradle tried to load it, there was something that was wrong about it, right? And what's happening here is that we try to store a naked configuration object. So even though it worked to store this object, the problem is this closure here, right, that the Kotlin compiler generated, right, the class that, or the Lambda expression, depending on how you're compiling your Kotlin code, the code that the Kotlin compiler generated behind the scenes used a type, right, that still references the configuration object, right? So behind the scenes, this closure here, this lambda, is still referencing a configuration object. And that won't work. The configuration cache won't allow you to do that. So what we need to do here, in the case of Kotlin, for now, is that we need to tell the Kotlin compiler to be a little smarter about this, or a little more conservative with the type, and just store the actual type that we need. In case of the configurations and like the capabilities we're using here are usually file collection capabilities, right? So that's a common fix. So I don't want to really store a configuration, but I want to store a file collection. And at this point, we have a few options, right? So we could say, okay, this is a provider of something, right? So I could get this guy and say, oh, it's a file collection, right? And then I don't need this anymore. So that's a suitable solution. It has downsides because now we're making we're doing this access at the configuration phase. Maybe we don't want to do that. Maybe we want to delay the get call to the execution phase. So I'm going to go with the lazier approach. Oops. So we're going to do this by first, I'm going to ask Kotlin to give me the type specifically, right? Explicitly, I mean. I simplify a few types here, and I actually want a provider of file collection. That won't work out of the box because of the way variance, generic variance works in Java, right? So Java generics are not covariant by default. That's the problem here, right? But Kotlin allows me to do this sort of on-site variance annotation to fix that issue. And this will be a proper fix. So either one will be a proper fix. I'm going to reload the script just in case. Make sure everything still loads. And now I'm going to run it. Just check for time. So let's run one more time. Let's do the rerun tasks. Here. The first time we should see configuration cache stored. And I'm going to run it again. That was really fast. And no problems, right? And you can see that in this case, since there are no problems and no build configuration inputs, we don't even get a link to the report, which is good. Okay, so now that we have fixed the issue, right? What we're gonna do is that we're gonna run the test again and see if the Gradle testing infrastructure agrees, right? So I'm gonna run that test. And I'm gonna already, yeah, that's great. So using the technique I just described to import the sample into IDEA, that is, I copied the wrapper from the root directory into my sample, right? I generate this error because the testing infrastructure wants to put its own wrapper, right, built from the current sources into that directory, but now it's already there. So that's a problem, right? So before running the test, so after you're done with like the IDE workflow, fixing the issues and all that, you should remove the Gradle wrapper. I'm gonna remove this. And when I run this again, I should have validation, proper validation of this. So I'm looking at the chat. There's a question. So Mike or Amanda, can you tell me which one is the one you like me to? It's the val runtime class path by configurations.existing one?
Yeah, that'd be a great one to start with.
Mm-hmm. Okay, so I'm going to put the Gradle wrapper back in. So my IDE still works. So if I can use by configurations dot existing, right? So then the problem here, right, is that it's going to be the variance problem again, right? So let's see if Kotlin type inference is cool with that. So existing, right, returns a lazy, so it's a provider, right, a lazy reference. In fact, I think existing is the same as this referencing the collection directly, so we could even skip that step. And let's see how that affects the execution. Yeah, so it seems all good. Oh. Yeah, so it doesn't like the, that's interesting. Let me bring the report here. Oh, let's build configuration input. So what is the failure? Interesting. So I guess we have a bug. So if we want to use that sort of syntax, what we could do here, I guess, would be like by getting. That would be the non-lazy version. And so we don't do get here. Then we have to say file collection, if that's possible. Interesting. So it seems we have some sort of inconsistency there that I wasn't expecting. Yeah. So this is another one of those constraints, right? So somehow we're now trying to capture a class loader here. That's interesting. I wasn't expecting that. So I guess we're going to have to look into that. And maybe for the next hackathon, we can have a demo that uses that syntax. For now, we're going to have to use the explicit assignment instead of the delegates. Yeah, thank you very much. So yeah, that's great. Another bug, another issue for the stable configuration cache milestone, and a more stable and better configuration cache in the end. Is there any other question that I needed to take a look at? Yeah, so there's a, have you considered adding DSL marker on top of do last, do first, so Kotlin forbids accessing build scripts. Yes, so that there's, I mean, we have considered, but we haven't really acted on that yet. So it's one of the issues that we want to tackle for the Kotlin DSL moving forward, to use DSL marker not only here but whenever, whatever, right? It can help us to prevent, right, those sorts of issues and captures. Yes. Is there any other question in the chat?
Well, I think since we're over time, we should probably sadly wrap it up, even though there's a few other questions that are still a little outstanding. So if there are more questions like this, where can they go for help? And is there some interaction with the Gradle engineers that they can have help from?
Yes, so we have also in the hackathon announcement, you can find the channel that we're going to use. So we have a public Slack channel for the community. We have a configuration cache channel in there, and that's the one we're going to use for this. So please chime in. Let's have a conversation there. So do you think we should wrap up here then?
Yep, let's wrap up. And next week, we're having a follow-up, right? We have a live Q&A session. So for the next week, people should start working and claiming issues, which we'll populate the board with. And then same time next week, right? We're doing a live Q&A.
Yes. Yes. That's it. So just one comment before we leave. So at this point, right, I'm ready to commit my fix. And just to save you some time, please make sure that when you commit, you sign off your commits using the -s. So that will save you some time interacting with the Gradle tooling on the GitHub side. And that's all I had for you today. Thank you very much, everyone. You've been great. And I'm really sorry for the technical difficulties we had starting this session. Amanda, back to you.
Thanks, Rodrigo. That was really great. And I just want to encourage everyone that's still here that, join our Slack channel. I'll post a link to the GitHub repo inside the chat here so that everyone can kind of go to the GitHub repo and start looking at kind of the rules, and then ping us in the Slack channel so that you can interact with these awesome build tool engineers. And until then, I'll see you guys next week.
See you.